Welcome to All This Math. This is Professor Parker. And before we get started on today's lesson on how to solve multi-step equations, I want to give a shout out to Malcolm X Liberation University. Now, Malcolm X Liberation University is not in existence right now. It was a short-lived university founded, I believe, in 1968. I want to say 1968 in Durham, North Carolina, before it relocated to Greensboro, North Carolina, not that far from North Carolina A&T University, where my sister graduated from. My sister Hanifa, shout out to her, North Carolina A&T University. Started by a brother named Howard Fuller, among many others. And it was a short-lived university, but it was an independent black college that you should check out and take a look into to learn the history of it. All right. So anyway, all right, now that we got that out the way, what I want to do tonight is I want to solve these two equations, right? But I want to solve them in two different ways. And I kind of just want to drive home the idea that in mathematics and in algebra, there's always, and always is a strong word, but there's always more than one way to do a problem, right? And it's important for us to learn these different ways so that we can find out like what way is most important or what way is most comfortable for us to use, right? When we're solving equations. So what I like to do, because this is my twist or my prerogative, is when I'm solving an equation that has parentheses in it, I like to just get rid of the parentheses from the rip. Just get rid of the parentheses. That's what I like to do. Unless there are fractions involved. If there are fractions involved, then no, actually, yeah, I still get rid of the parentheses. That's what I do. I get rid of the parentheses, and I do that by using what's called the distributive property. All right, the distributive property. Now, what the distributive property says is this number that's outside of the parentheses like this gets multiplied by each term inside the parentheses. And then just like that, the parentheses are gone because they're not needed anymore because you don't need to separate this quantity from this 3. All right, so now what I'm going to do is I'm going to do 3 times negative 6n, which is negative 18n. And then I'm going to do 3 times negative 5, which is negative 15. And then over here, I'm going to do 75 right there, right? And now I got a couple things I want to do. I'm trying to isolate this n by itself because that's essentially what I'm doing when I'm solving an equation. I'm locating a variable and I'm trying to isolate that variable in one place by itself on one particular side of the equal sign. This is already on the right side of the equal sign. So what I'm going to do is I'm going to get rid of everything else that's also on the right side of the equal sign so that the n will be isolated. So the first thing I'm going to do is I'm going to get rid of what's furthest away from it, the negative 15, because the negative 18 is right up on it. The negative 18 is its coefficient. So that's closer, so I'm going to get rid of that second. I'm going to get rid of this negative 15. So I'm going to do the opposite operation, which is adding 15, because we do inverse or opposite operations to get rid of things when we're solving equations. That's just what we do. That's just how it gets done. So if I add 15 on the right side of the equation, I also need to add 15 on the left side of the equation. So boom, that turns into a 0. 75 plus 15. We need to know how to do our arithmetic. 75 plus 15 is 90. Bring the equal sign down. Bring the negative 18n down. If you want to, draw an arrow. You know, whatever. You want to get a little artistic, it's cool. All right, now I got 90 equals negative 18n. So I want to solve for n, like I told you. I still want to solve for n. So I need to get rid of this negative 18. Now, how do I get rid of the negative 18? That's the question. You always do the inverse or the opposite operation of what that term you're trying to get rid of is involved in currently. So this negative 18n means negative 18 times n. Times means multiplication. The opposite of multiplication is division. So we're going to divide by negative 18 right here. And we're also going to divide by negative 18 over here. Boom, boom. They turn into ones. 90 divided by negative 18 is negative 5. And that's equal to n, which is all by itself, isolated on the right side of the equation. And no, in case you were wondering, it doesn't matter if the n is on the right side or the left side of the equation. As long as it's isolated all by itself. That's all that matters. That's all we need to do. Make sure that it's isolated. So we got n equals negative 5. But hold up, though. You don't want to stop until you've checked your work. You need to check your work. Always go back. So take this negative 5, plug it into the original equation. Make sure that it checks out. Make sure that the left side matches up with the right side. So let's do that. If I think n equals -5, then let's do -6 times -5, which is positive 30, because a negative times a negative is a positive. Remember that. So that's 30. And then 30 minus 5 is going to be 25. And then 25 times 3 is equal to 75. So that's proof that that's correct. All right. Now, notice how I said there are multiple ways to do or to solve equations and to do problems such as this. I like to distribute. That's just what I like to do. But you don't have to do that. There's another way. And after this other way that I show you, there are even other ways that you could do these types of equations. You can solve these types of equations. So what I'm going to do is another method, which is division. That's another way to get rid of this 3. You get rid of the 3. Instead of getting rid of the parentheses first, you get rid of the 3. So what we'll do is, because 3 is being multiplied by this quantity, I can do the opposite of multiplication, which still is division and always will be division. So what I do is I do this right here, divide by 3 on the right side of the equation. And I also divide by 3 on the left side of the equation. Now 3 divided by 3, those turn into 1s. So now the 3 is gone, right? Because my goal is still to ultimately get this n by itself. So I need to get rid of everything on the right side of the equation. So I'm going to get rid of this 3. Then I'm going to get rid of the -6. I'm going to get rid of the -5. Well, not in that order, but you know what I'm saying. I'm getting rid of all 3 of those terms, all right? So now on the left side, I need to divide by 3. So 75 divided by 3 is 25. And now I'm left with just -6n minus 5. And now notice how I didn't write the parentheses, because I don't even need them no more. Because all I have is just -6n minus 5. I'm not separating -6n minus 5 from anything anymore. All I got is just -6n minus 5. So now I'm basically going to do something similar to what I did over here, even though my numbers look different. But watch what ends up happening, though. I'm going to get rid of this -5. I'm going to do the opposite operation. The opposite of subtracting 5 is adding 5. So I'm going to add 5 on the right-hand side. Then I'm going to add 5 on the left-hand side. Boom. 25 plus 5. That gives me 30. Bring the equal sign down. Bring the -6n down. What's -5 plus 5? 0. That -5 is gone. Just like I wanted. I wanted that -5 gone. It's gone now. So now I got 30 equals -6n. And again, my goal is to get n by itself. Right? Get n by itself. So I'm going to get rid of this -6 by doing the opposite operation, which in this case will be division. On the right side, and division on the left side. The -6's cancel out. They turn into 1s, leaving me with just 1n over 1, which is just n. Now, I end up with 30 divided by -6. And look what happens. We know that 30 divided by -6 is -5. -5 equals n. Didn't I say -5 was equal to n over here? I did. So you see what happened? We started this problem out. I wrote it down 2 separate times, started it out in 2 separate ways, and I ended up with the same answer. And I don't need to check it again because I already checked that -5 was correct. So -5 is correct. I already checked it. All right. So what this also goes to show us is that it's not necessarily always about how we start, but it's about how we finish. Right. And even in mathematics, so you have mathematics giving us and manifesting life lessons, right? Not necessarily how you start, but it's much more important sometimes to consider how we finish. All right. So, and this is just a little multi-step equation that includes parentheses, and I just wanted to show you a couple ways that we can solve those types of equations. So, please like the video, please subscribe to the page, please tell your friends, tell a friend to tell a friend. And always do remember that there's all this math all around you. Peace.